Hi everybody, hope you're doing well. If you're watching this, that means we're at the end of week 4 already. We're in Unit 8 still, Section 8. We're getting close here to the end of this gigantic chapter on exponents and logarithms. Today we are going to talk about how to solve logarithmic equations. So this is going to kind of follow up with what you learned in the previous lesson about exponential equations. Like I said, these are all intertwined, and you'll see that here as we go through the work today. There's not as many examples here, and there's not as much to deal with in these problems compared to what you learned in the previous lesson. But ultimately, we're going to look at this here in a couple of stages. We'll take a look at the real basics of how you solve these, and then look at, when they're not as basic, what exactly do you have to do. So let's go ahead and talk about this property in general. So kind of similar to the exponential property. As long as your log functions have the same base, then these values here, the x and the y, they will be equal to each other. So if I had something like log base 2 of x equals log base 2 of 7, the fact that my bases are the same, so just like the exponent functions, if my bases are the same, that means these guys right here have to also be equal to each other. So I would say x equals 7. And if there's more to it mathematically, if those had like x minus 8 and 2x plus 12, we'd set them equal to each other and solve. This will also hold true if we're dealing with natural logarithms, so that ln. So if I have ln x equals ln of 8, again, since natural logs are on both sides, it's the exact same base. It'd be a base of e technically, but they're the same thing. So that would become x equals 8. I'd set those pieces equal to each other. So we're going to look at a couple of real basic problems here where we're going to see the same base, do some basic math, and then we'll go ahead and take a look at when we don't see the same logarithmic base on both sides. So here in number 1, I see log base 5 of 4x minus 7 equals log base 5 of x plus 5. And again, the key to this is those bases are the same, which is awesome. So what that means is I'm going to go ahead and take the 4x minus 7, the x plus 5, and make them equal each other. So again, do some quick algebra here. Subtract the x, add the 7, divide by 3, and we get that x equals 4. And again, we can do a quick check by plugging in to our functions here. So I have log base 5 of 4 times 4 minus 7 equals log base 5 of 4 plus 5. Again, do some quick math. I get log base 5. That becomes 9. And same thing on the other side. So let's check out. Awesome. Cool. We got the right x value. That's the ultimate way you can check them. And you can use your calculators if you want to evaluate further. Number 2, I see the same thing. So this is even easier because I see the same, that natural log notation, ln. So I don't even really need to look for a base because if it's natural log, they're e's. We're done. So all I have to do here again is take these two components, the 7x minus 4, and set it equal to the 2x plus 11. Subtract the 2x, add the 4, divide by 3. X equals 3. And again, I can plug that in and check it. I would end up with, on both sides, a natural log of 17. So, again, that's the very easy version of it. Same base. That's going to make your life a whole lot easier. Where you're going to have to do a little bit more work, but I don't think it'll be as maybe complex as what we did in the last lesson, is when you don't have log on both sides, how do we solve it? So, one thing we'll talk about here, and this will really come up, I think, in just the last problem, and we'll deal with it here in a minute, is we're going to go ahead, if you have a logarithmic equation, so you can see in all of these problems here, the log is on one side, and the other side is just some integer of some sort. If you only have log on one side and you have to solve an equation, basically we're going to do what we did the opposite of in the last video. So the last video we took exponential functions. When I couldn't do anything with them, I made them logs. We're going to do the same thing here, but in reverse. I have log functions. If I look at them as is, I can't go anywhere with them. So I'm going to go backwards and turn them into exponential functions. So these first couple here are going to follow a pretty similar pattern. So I have log base 4 of 5x minus 1 equals 3. Again, I only have the log on one side, so I can't just cancel things out and say, oh, 5x minus 1 equals 3, let's go solve. Not quite that simple. So what we're going to do here is write this as an exponential function. So again, to do that, you take the base of the log, that becomes the base of your exponential function. The exponent is what the log function is equal to. So the log function is equal to 3, that is my exponent, and I set that equal to the final value that's left over, the 5x minus 1. Once I do this, this is a lot easier to solve. 4 to the third is 64. Add 1, you get 65. Divide by 5, x is 13. And again, you can always plug that in and check, do the math yourself, but ultimately, x will be 13, and that'll work itself out very nicely. If you want to hit the pause button, try that in number 4. It's the exact same template. Again, you have a log on one side, not a log on the other, so we have to turn it to exponential form. You want to try it for a minute, hit pause. Otherwise, let's go through and figure this out. So I have a log base of 2. That means my exponential base will also be 2. The exponent is 5 because that's what the log function is equal to. And then my final value, that x minus 6, is what my exponential function will be set equal to. So 2 to the 5th is going to equal x minus 6. 2 to the 5th power is 32. Add the 6, x equals 38. So again, I've emphasized a lot in these last few videos here, going back and forth between exponential and logarithmic form. As long as you're putting those things back and forth in the right places, again, shouldn't be hopefully too complicated, and hopefully you're seeing that here with these couple of examples. It's not really complex math as long as you know how to rewrite it. As long as you know, again, how to do that first step, how to look at it and go, oh, I don't have all the info I need, let's go rewrite it another way, and all my values will line up a lot better. Again, practicing that will be super helpful. Now let's take a look at a problem like number 5. So you notice this one's a little bit different because I see 2 logarithmic expressions. Log 2x plus log of x minus 5 equals 2. Now, I can't just move log to the other side and cancel out log, because the problem is I have this regular old 2. That's in the way, so I can't exactly just say, oh, let's move one log function to the other side and cancel things out. Not so fast. What I have to do here is this. So this is going back to a couple videos ago where, hey, if I have 2 of the same function, or 2 of the same logarithmic base, I should say, how can I combine them together as 1? If I'm adding the same type of log function, that means I can rewrite it as a multiplication problem. So I can rewrite this as log of 2x times x minus 5. I can combine this together as one log function. And you'll see why this will be really helpful here in just a minute. So I have log of 2x times x minus 5 equals 2. Now what I can go ahead is put the 2x here with the x minus 5 and call this 2x squared minus 10x. Now, this should look a lot similar to what we did in 3 and 4. Now I have one singular log on the left, nothing on the right. That's logarithmic-wise anyway. So, I'm going to rewrite this as an exponential function. But again, I just see log. Well, again, think back to a few lessons ago. If I have just a regular log, that means it has an invisible base of 10. So, when I see just log, it's like it's log base 10, which means the base of my exponential function will be 10. 10 to the second, because again, my log function is equal to the exponent. And then I pull down what's left, the 2x squared minus 10x. So, we make 10 squared equals to 100. Now, if this were just 10x, or even just 2x squared, this would be pretty quick to solve. But we know with problems that have 2 different types of x's, and this is something that I used to love doing all year. We haven't done it in a while, but it's my old favorite. We're going to need to solve this problem by factoring. And I can already hear the level of excitement in your brains and in your voices all the way over here through my iPad. So let's go ahead and talk about how do we solve this. If we are solving a problem that requires factoring, so again, your clue is going to be two different types of x's, an x squared and a regular x. If we are solving by factoring, we should set this equal to 0. So to set it equal to 0, I'm going to subtract 100 from both sides. So it's going to look like 2x squared minus 10x minus 100. Now, there's a couple ways we can do this. I'm going to do it the quickest way possible here. If you look at all of your terms are divisible by 2. So I'm going to go ahead and divide that 2 out of everything. Because it's a GCF, I can take it out and it's inconsequential to the problem. So I can whittle this down to 0 equals x squared minus 5x minus 50. Now, once I do this, now we can factor this using trial and error or trinomial strategy. So what multiplies to negative 50 adds to negative 5. The two numbers that will do that are negative 10 and positive 5. Once we're here, zero product property, set each little factor equal to 0. So again, as you may recall, so that would be x minus 10 equals 0, x plus 5 equals 0. X would equal 10, x would equal negative 5. Now, both of those answers, mathematically, right now, they come out great. But there is a problem with one of them. So this is something I think I briefly referenced a little bit a couple of videos back, and it's not something, again, I'm going to really need you to worry about with all the stuff that's going on right now, but I'm going to explain to you why they both don't work. 10 works fine if I plug it in, okay? Because if I plug it back in to what's up top, I get log of 20 plus log of 5, and all that stuff works out beautifully. If I plug in negative 5, what I end up having to happen is I'd have log of negative 10 and log of negative 10. While you have the same expression there, you can't take log of a negative number. That's a problem. So whenever I substitute it into a logarithmic expression, I have to be able to have something that's greater than 0. Okay, or greater, it shouldn't be a negative number, I should better say. If you have a negative number and trying to take log of that negative number, your calculator is going to scream at you. Negative 5 does not work in this case. 10 is actually your final answer. So if you look at that note a little carefully at the top, it talks about extraneous solutions. Negative 5 is considered extraneous because, again, mathematically it spits out, but it does not quite give you the correct answer. So, little review there of our good friend factoring. Again, I'm sure it's something you would love to never see again, but it always seems to rear its ugly head back around. Ultimately, if you can do problems like 3 and 4, you will be in good shape for what this section requires and for what you're going to do with your practice and your graded assignments. So again, number 5 is not meant to confuse you, but ultimately to show you we can do more than just the same pattern over and over again. So take that for what it's worth. Ultimately, though, if you can do problems like 3 and 4, I think you will be in very good shape. So, just like the last video, again, I would definitely do a couple of the practice problems that I've provided for you before you go right into the graded assignment. Make sure you know what you're doing and what you're doing is correct. So, just like always, if you're having issues, you need any help, send me a Schoology message, shoot me an email, or hop on Zoom during my office hours. As always, as I keep offering to all of you, I will be more than happy to help you with anything you need. Otherwise, thank you for watching, stay safe, stay healthy, and we'll see you next time.